Assalamualaikum students. I hope you are well and learning is easy with this channel. I'm going to continue the topic of isomerism. Last time हमने isomerism पढ़ा था. Isomerism की definition हमने पढ़ी थी कि जब दो compound जिनका molecular formula same हो but उनका chemical structure different हो उनको हम कहते हैं आइसोमर. ऐसे कंपाउंड जिनका मॉलिक्यूलर फॉर्मूला सेम है बट उनका केमिकल स्ट्रक्चर जो है वो डिफरेंट है तो उसको हम कहते हैं यार दे आर आइसोमर्स. नाउ आइसोमर्स में हमने कॉन्स्टिट्यूशनल आइसोमर्स को डिटेल में कंप्लीट कर लिया है. अगर आप चाहें तो इसकी प्रीवियस वीडियो चैनल पर देख सकते हैं. आज की क्लास में हम स्टीरियो आइसोमर की एक स्पेशल टाइप ऑप्टिकल आइसोमर को डिस्कस करेंगे. Just to recall what is stereoisomer, I've just written the definition over here. ऐसे कंपाउंड जिनका मॉलिक्यूलर फॉर्मूला सेम हो और कनेक्टिविटी ऑफ एटम्स सेम हो बट अरेंजमेंट ऑफ एटम इन स्पेस या 3D अरेंजमेंट जो है वो डिफरेंट हो उनको हम स्टीरियोआइसोमर कहते हैं. हाउ देर आर टू स्ट्रक्चर्स, कार्बन connected with CH3 and hydrogen. Another side it is also connected with CH3 and hydrogen. If we look for two connection of each carbon, the hydrogen is small group and the CH3 is bulky group. Bulky means heavy group. So on carbon number 1 and carbon number 2, the bulky groups are on opposite side. That type of arrangement is known as trans. I have discussed in detail like what are cis and trans isomerism in last video, but just I'm going to give an overview so that we can connect this thing to the next topic. The B structure is also same, 2 carbon with attachment CH3 and hydrogen each side. इस side पे भी CH3 and hydrogen है, इस side पे भी CH3 and hydrogen है. But what is the difference? In A and B, in B structure, the bulky group are on same side. As we observed, the bulky group were on opposite side in structure A, but in structure B, the bulky group are on same side. So that one is known as cis structure, CIS, cis structure. Okay, so that is known as cis structure. That was the geometrical isomerism that we have completed in last class. In today's class, we are going to target optical isomerism and the two types that are enantiomer and distereomer. If we talk about the simple formula that we have like 2,3-dichloropentane. I'm going to write the formula over here for 2,3-dichloropentane. 2,3-dichloropentane. The possible structure would be as it is pentane. So 5 carbon are there. Carbon number 1, 2, 3, 4 and 5. It is N, that means all carbon are connected by single bond. Another information that is given is 2,3-dichloro. So if I place chlorine group, so I can place on position 2 and position 3, and the rest of the valencies of carbon I'm going to fulfill with hydrogen. It is only bonded with one carbon atom, so 3 hydrogen would be there. The second carbon is bonded with 3 atoms, so 1 hydrogen would be there. Again 1, 2 and 3. As the valency of carbon is 4, so we have to fulfill. Now that is not the final structure. There are 4 possibilities for this compound. If I make the Fisher projection, what is Fisher projection? The representation of this compound in more visible way. So we have first CH3 group like this one, the carbon number 1, CH3. I'm going to draw it over here, CH3. Okay. Then we have carbon number 2 and 3 on which chlorines are attached. And that one I'm going to take as a complete group C2H5. If I write it C2, CH2, CH3 or collectively I write it C2H5, both are correct in Fisher projection. So I'm going to start chain with CH3 and end chain with C2H5. As we can notice, we have mentioned only terminals, but the central carbon are missing. So there are two central carbon. I'm going to represent like this, carbon number 2 and carbon number 3. On carbon number 2, the two attachments are H and Cl. So I'm going to put H and Cl. Again, on carbon number 3, there are two attachments H and Cl, right? So that is the structure of 2,3-dichloropentane. But what if I arrange the chlorines on this side? Like both chlorine, I'm going to arrange this time on this side. So we have same C2H5 one terminal, CH3 another terminal, first terminal, and two chlorine and two hydrogen on these central carbons. So here we also have carbon number 1, 2, 3, 4, and 5. So if we look in structure A and B, these two structures are mirror images. If we like keep a plane that is mirror over here, so structure A and B seems to be mirror image. These are mirror images. So those compound which have same molecular formula, same connectivity, we can see on carbon number 1 there are 3 hydrogen, on carbon number 2 there is hydrogen chlorine, carbon number 3 hydrogen chlorine, and carbon number last we have C2H5. Similarly in this carbon number 1 CH3, related to this on second carbon we also have hydrogen and chlorine, on third carbon we have hydrogen and chlorine. So their connectivity is same, molecular formula is same, connectivity is same, but their orientation of atoms in space is different. That's why these are stereoisomers. And those stereoisomers that are mirror image of each other and are not superimposable, they are known as enantiomer. What is the definition of enantiomer? The two stereoisomers that are mirror image, but not superimposable, not super impossible, right? So the two stereoisomers that are mirror images and not impossible, they are known as enantiomer. What is this? This is enantiomer, right? So what is the meaning of super impossible? Like if I take structure B and keep it on structure A, if I completely this molecule, if I hold it and place it over here on this molecule, so CH3 will cross CH3, C2H5 will cross C2H5, but this chlorine being bulky in nature can hide. This hydrogen being light in nature cannot hide this chlorine. So if I place इसको मैं completely उठा के इस molecule के ऊपर रख दूं तो क्या होगा, अभी भी क्लोरीन हमें नजर आएंगे. दोनों क्लोरीन क्यों नजर आएंगे? क्योंकि यहाँ पर दो small atoms are attached which cannot hide chlorine. So that means structure B is not superimposable on A. Similarly, अगर मैं structure A को B के ऊपर pose करूं तो अगेन हमें वही प्रॉब्लम यहाँ पर फेस होगी कि यहाँ पर हाइड्रोजन इसके ऊपर आएगा एंड हाइड्रोजन कैन नॉट हाइड क्लोरीन. ये वाला हाइड्रोजन इस क्लोरीन के ऊपर आएगा, दैट मीन्स दिस हाइड्रोजन कैन नॉट हाइड क्लोरीन. सो दैट टाइप ऑफ अरेंजमेंट इज कॉल्ड नॉन सुपर इम्पॉसिबल अरेंजमेंट, राइट? ऐसी अरेंजमेंट जिसमें एक पूरा मॉलिक्यूल दूसरे मॉलिक्यूल के ऊपर रखने से वो उसके तमाम एटम्स को हाइड नहीं कर सकता, तो उसको हम कहते हैं these are non superimposable. If the compounds are non superimposable mirror images, they are known as enantiomer. Now, what about the third arrangement that I'm going to make over here? Like if we have CH3, previously we had CH3, And the last group is C2H5, like previously we had, but we had C2H5. Now, in this center, we were having two bridges, the first one and the second one. If I keep chlorine on opposite sides, like on second carbon, we were having the possibility of hydrogen and chlorine. So it is not possible that all the time both chlorine should be on same side, like this side or this side. It is also possible that one chlorine should be trans to another chlorine. So that is also with same molecular formula, same connectivity, but now the structure B and C. I must say this one is structure B and C. These are not mirror images, right? The structures that are not mirror images of each other and not superimposable but have same molecular formula, same connectivity order are known as diastereomer. Okay, these are diastereomer. So if I look for the example A and C, A and C are also having same molecular formula, same connectivity, but they are not mirror images, nor they are superimposable. So we can see A and C are also what? Diastereomer. Let us take one more possibility for this compound. The fourth possibility that we have is CH3. At the terminal, we have C2H5, right? So in the center, we were having two bridges, the bridge number 1 and the bridge number 2. So if I keep this time chlorine here, hydrogen here, again hydrogen here, chlorine here, this structure must be structure D. Now if I place a plane in structure D and C, are these mirror images? Yes, they are mirror image of each other because chlorine is facing chlorine, H is facing H, C2H5 is facing C2H5, and CH3 is facing CH3. So we can say that C and D are mirror images. But are they superimposable? If like I keep structure D on structure C, what would happen? This chlorine will face this CH3 will hide this CH3, this hydrogen cannot hide this chlorine. That means these are mirror images, but they are not superimposable. So we can say the structure C and D are enantiomer. Why? Because they have same molecular formula, same connectivity order, different orientation of atom in space, and they are mirror images but not superimposable. So these are the criteria on which you can identify different compound as diastereomer or enantiomer. Thank you.